Okay, so what we're going to do now, if you watched my last video, chapter 4.4, video 1, we found the derivative of y equals e to the x, and we discovered that, in fact, the derivative of e to the x is just itself. It is also e to the x. Now what we want to do is generalize a bit more and say, well, what about some exponential of any base a? And let's just use definition of derivative. The derivative of y with respect to x equals the limit as h goes to 0 of a to the x plus h minus a to the x over h. And you're going to notice that this is very simple. We can very simple. It is simply just like what we did before. This is a to the x times a to the h minus a to the x, all divided by h. I'm going to factor out the a to the x. And when I factor out that a to the x, because it is not a function of h, I can just move it straight out in front of the limit. And so I get a to the x times the limit as h goes to 0 of a to the h minus 1 over h. Now, we do have a little bit of a problem, is that when a is equal to e, this is 1. This is not equal to 1 for most values of a. And if you want to double check me, go ahead and type in 5 to the h minus 1 divided by h, and you'll see that, in fact, you get a different value. So unfortunately, this doesn't work. We're at a bit of a standstill here. So we're going to try a new strategy. Okay, new strategy. Here we go. I could rewrite a to the power of x as e to the natural log of a to the x. And I apologize that this is blinking on and off. It was supposed to be fixed, but I'm going to get rid of that. Very frustrating. Little things. Remember, e to the power of natural log, just they cancel each other out. They're inverse functions. So e to the power of natural log cancels each other out. We're left with a to the x. And then, because of a property of logarithms, I could rewrite that as e to the natural log of a. Excuse me, e to the x times the natural log of a. So let's take the derivative. Well, the derivative of a to the x, which is what we're trying to find, equals my chain rule. There's my outer function. There's my inner function. So my chain rule says that it's the derivative of the outer function, which is itself, times the derivative of the inner function. Well, the derivative of natural log of a times x, notice I'm rewriting it in the opposite order. Well, that's just a constant. Natural log of some number is a constant value. So the derivative of that is just the natural log of a. This, however, going back a step, is just a to the x. So this derivative is equal to a to the x times the natural log of a. So now we can just rewrite this in a slightly more convenient order. It is itself times the natural log of whatever that base is. All right, let's do a quick example and use this at example 2. And we're not just going to take another derivative because, we've done that a lot. We've got the function y equals 2 to the t minus 3. And the question is, at what point does this have a tangent line with a slope equal to 21? Now, a couple things to be careful of. First of all, you are asked for a point, so make sure your answer is in the form of a point. And second of all, tangent line with a slope of 21 tells us that we need y prime equal to 21. The derivative must be 21. So let's find the derivative. The derivative of y is, well, natural log of 2 times 2 to the t minus 0. Derivative of negative 3, don't forget that. And this must equal 21, which means that 2 to the t is equal to 21 divided by the natural log of 2. And remember that the way to solve exponentials is to take the log of both sides. So we'll just stick with natural log of 21 over natural log 2. And the t comes out front, and we get t times the natural log of 2 is equal to the natural log of 21 over natural log 2. And that tells us that t is equal to the natural log of 21 over natural log of 2, all divided by the natural log of 2. Now, you could fiddle with that and do change of bases, but honestly, it's really not worth the effort. Type that into your calculator, and what you get is that t is approximately 4.921. This might be a good place to talk about the STO function on your calculator. If you have a TI graphing calculator, it's got a button that says STO. You don't want to round this off right now. You know, for the purposes of writing it down on my page, sure, writing 4.921 is fine. But I want to calculate the value of y using the full value. So if you type STO and then use the answer function, it will store the whole number into your calculator register. And oh wow, I might be missing a step. Do you have to tell it where to store it? Hey, you know what? I'm gonna let you jump online and do a quick bit of digging because I don't want to stop the video right now. Wow, I believe I'm not recording at all. Am I recording? I don't even know if I'm recording. All right. I'm going to end this video here just very quickly. You're going to take your 4.921. You're going to plug it into y, and you're going to get 27.297, and your point is those two. If you're in my class, just in case this is still recording and things are getting weird, go ahead and do exercise 29. And we'll be back with the next video.